We already said that a four-sided figure is called, what did we say it was called? We said it was called a quadrilateral. So we'll write that down here. Quadrilateral. Okay, it's a quadrilateral. And all that means is it has four sides. Okay, that's all it means, quadrilateral. Okay. Now, over here, we have one family of quadrilaterals we want to talk about called parallelograms. And parallelograms are kind of cool. They kind of look like exactly how they sound. They're shaped with parallel lines, parallelograms. Okay, so I'll write that down here. Parallelogram. Parallelograms. Okay, all it means is two pairs of parallel lines. So here's a parallel line. This is parallel to this. This is parallel to this. Okay, that's a parallelogram. Now, of the parallelogram family, you have a couple of different choices here. One of them is a very familiar rectangle, which you already know, right? That looks like a rectangle. I'll just put that down, rectangle. And the definition of a rectangle is four congruent angles. Now, this may not be the definition that you learned when you were in second grade, but really in geometry, it just means that the four angles inside here are congruent. They're equal to one another. The lengths of the sides have nothing to do with it, which you already know. A rectangle can be very big or very short or whatever, but it just has to have the four angles be congruent, which also means that they have to be 90 degrees, by the way, four 90-degree angles. Okay? And let me go down here and say, well, there's a special kind of rectangle I think you all know about called square. Okay, so this is a square. And the definition of a square is four congruent angles and four congruent sides. Okay, so four equal sides and four congruent interior angles that go 90 degrees. So that's a square. Now backing up the truck here up to parallelograms. Splitting off here, you have another family called a rhombus. Okay, so here you have these guys here. This is a rhombus, and so you have four congruent sides. Okay. Now I want to talk a little bit about this side of the family here, just to make sure you understand how I'm drawing it. What I'm saying is that any four-sided shape is called a quadrilateral, and of all of the shapes that have four sides, you have a certain family of them that have parallel sides, where these two lines are parallel and these two lines are parallel. That's called a parallelogram. Okay. Now, if the shape also has the same angles all in all four corners, then that's called a rectangle. And then further, if that shape has the same length side, in addition to the angles being the same, it's called a square. Now, that's the same thing you already know. And then backing up the truck here, if you have a parallelogram with parallel sides and also congruent sides, congruent sides meaning that the lengths of these sides are all the same, but the angles aren't the same, because that would be a rectangle or a square. Then this is called, I even forgot to tell you what it was called. It's a rhombus. Okay? So, you can just kind of think about it. You know what a rectangle looks like. You know what a square looks like. A rhombus is kind of a tilted square, really, because the lengths of the sides are the same. And these lines are parallel. That makes a parallelogram. Now, backing up the truck even further to the quadrilateral, let's go off and look at this side over here. Okay? Another four-sided shape that you're going to see a lot of is called a trapezoid. Okay. And what would make a trapezoid? Let me write that down first. Trapezoid. How would you define a trapezoid? Trapezoid, it's one pair of parallel lines. So as opposed to the parallelogram where you had both sides had parallel lines, this is only one side has parallel lines, or one pair of lines are parallel. The other two are not. They're just some random angles. That's called a trapezoid. And then there's kind of a subfamily underneath that, and this is most of the trapezoids you'll see in your book. where it's just kind of drawn in this nice symmetrical, you know, a symmetrical shape. Here you have parallel line, nice length side, nice side like this, exactly the same, angled in exactly right. This is called an isosceles trapezoid. Okay, isosceles trapezoid, and it just means that the legs are congruent. So backing up the truck, looking at this side, four-sided shape called a quadrilateral can yield a trapezoid if only two of the lines are parallel. The other two do not have to be parallel. And then of the trapezoid family, if all of the legs are exactly equal to one another, so you know you're going to get rid of this junk here and you make it look beautifully symmetric and with the same length legs and everything else, then you have what's called an isosceles trapezoid. So this is kind of a roadmap of a quadrilateral family, and we're going to use that to look at a few properties and theorems that you'll see in your book. They'll be kind of rapid fire, but the good thing about a video is you can watch them over and over again so you remember them. Okay, and that's what we're going to do here. We're going to go over those. Okay, what we're going to do is first we're going to talk a little bit more about parallelograms. Okay, here is a definition, and these are all going to be related to parallelograms. Here's a definition: opposite sides of a parallelogram. By the way, I'm using this term to mean parallelogram, parallel lines to gram, okay, are parallel. Now, some of these are going to just be obvious from what we talked about before, but let's go ahead and go over them. If you have a parallelogram, in pictures, what I'm trying to say here is opposite sides of a parallelogram are parallel. So that would mean this is parallel with this. That's what these little triangles mean. And this one here is parallel with this one here. That's all that means. Opposite sides of a parallelogram are parallel. That's what the definition of a parallelogram is. This is parallel with this is parallel with that. That's it. These are going to be kind of rapid fire, but these are going to be things that you need to remember to do your homework. Okay? Opposite sides of a parallelogram are congruent. Okay, let's look at what that one means. Again, if you have a parallelogram, here's your parallelogram. All it's trying to say is that this side's congruent to this side. That's what the line means. This side is the same length as this one, and this side is congruent with this one. And I think you can kind of see that even from just looking at the picture. This side is going to have to be the same length as this, and this side is going to have to be the same length as this. That's what this line means, and that's what these double lines mean. Okay? Okay. Consecutive angles in a parallelogram are supplementary. Okay, what does supplementary mean again? Way back at the beginning of the class we talked about that. Supplementary angles are just angles that add up to 180 degrees. Okay, and let's look at that. So if we have, you know, here's a parallelogram. Okay, and let's just say, for instance, that this is a 60-degree angle, and this is a 120-degree angle, and this is a 60-degree angle, and this is a 120-degree angle down here. All it's saying is that consecutive angles, angles one right next to another, like this one and this one, these are called consecutive angles. They have to add to 180. These have to add to 180 because they're consecutive. These have to add to 180 because they're consecutive, and these have to add to 180 because they're consecutive. Okay, that's what the supplementary means. Okay, that they have to add to 180, and I'll just put that here. Add to 180 degrees. Okay, so that's just something you're going to have to remember. And let me write another one down here. Diagonals of a parallelogram bisect each other. And I'll show you what I mean by that right here. What I'm trying to say here is that if you have a parallelogram, okay, diagonals are the lines that go from one corner to another. So let me draw in a different color and show you what I'm talking about here. if this is one diagonal and this is another diagonal, all this is saying is that these two lines cut each other in half. Okay, this is one diagonal, this is another diagonal. This diagonal cuts the other one exactly in half, so this is the same length as this, and this is the same length as this. So they actually just cut each other right at the middle. So this point where they intersect, it slices this one in half, and it slices this one in half. And that's always going to be the case, no matter what size or shape of a parallelogram you draw. If you draw diagonals, they're going to crisscross such that it cuts this line in half, and it cuts this line in half. That's what bisect each other means. That's what the word bisection means, to cut in half. Okay? So let's do a little bit of practice. Let's use our properties here, and let's go ahead and apply it to some problems. So let's say you had a parallelogram. Okay, here's the parallelogram right here. Okay, and this corner is A, this corner is B, this corner is C, this corner is D. Okay, and all I'm given in the problem is that this length is 9, this length is 12, and this angle is 30 degrees. That's all I'm given. I'm not given the length of this side or anything else, and I'm going to find a few things. So let's see, what do we want to find first? What is the length of BC? BC here. Okay, what would that length be? And what property would we use? Well, we would use the property that opposite sides of a parallelogram are congruent. So this is an opposite side of this here that we already know is 9, so BC must be equal to 9. And you can kind of see that just from the picture. I mean, it looks to be the same length. Okay? DC, what would that be? Well, that's opposite of 12. Same thing, opposite sides congruent, so that's 12. Okay? Angle B, what would angle B equal to? This is angle B. What would that one equal to? Well, if we look back over here, consecutive angles in a parallelogram are supplementary. They add up to 180 degrees. But you can also see from this picture that opposite angles are the same. And I think you can also see that just from drawing any of these things, is that this angle is kind of an acute angle, and this angle is an acute angle, and this angle is an obtuse angle, and this angle is an obtuse angle. In any parallelogram you draw, the opposite angles are going to be the same. So we can apply that here, and we could say the opposite angle to 30 degrees is just going to be 30 degrees. So B is going to be equal to 30 degrees. And you can see it kind of looks to be the case. Okay? 4, angle A is equal to, what's angle A equal to? This guy right here. Well, this is a consecutive angle, and we learned from our theorem there it has to be supplementary. So what we'll do is we'll say it's going to be 180 minus 30, which is equal to 150 degrees. Okay? Because these two angles are consecutive, so they must add up to 180 degrees in a parallelogram. So we just take 180 minus the 30, and so this one must be 150. Now we're going to go on and do a different one. Let's draw a different parallelogram, kind of a more vertical parallelogram like this. Okay? And all I know about this is labeled S, this is labeled R, this is labeled P, and this point is labeled Q. Okay? And I've also got a few more pieces of information here. I've got a couple bisections going on here. Okay? We talked about bisections. This angle is 20 degrees. This angle is 45 degrees. The length of this side right here is 5, and the length of this side right here is 7. Okay? And the point in the middle I forgot to label is a point O. This is not a 0. This point of this intersection there is point O. So what do we want to find? Let's say we want to find a few things about this just to practice. SQ. What is the length of SQ? SQ is this right here. Okay? Now we know that this is a parallelogram, and we know that these two diagonals bisect each other. We already said they cut them in half. So if this length is 7, then this length must also be 7, because this is a bisector and it cuts it in half. So if this is 7, this must be 7. So 7 plus 7 is 14. Right? 7 plus the 7 is going to give me 14. So what if I'm looking for OR? This one here. What would this one be equal to? Well, again, this is two diagonals that are bisected, so if this length is 5, then this length must be the same thing because it's bisected, so it must be 5. Okay, so the trick is just to look at what it's asking for and try to apply one of the theorems that we learned to that. Angle PQR, what would PQR equal? PQR, which is this entire angle here. PQR, this entire angle, what would that one be equal to? Well, we know that this angle, this giant angle here, is going to be the same thing as this giant angle here because they're opposite angles. And we know that this angle here is just the sum of these two. So all you have to do is go 20 plus 45 is 65 degrees. So this angle PQR is 65 degrees because it's the same thing as this angle here, which you can just add those two angles together, 20 plus 45 to get your final angle. SPQ. What if I want to find S, where's P? PQ, SPQ, this angle right here. How would I find that angle right there? Well, if I'm interested in this angle right here, remember this giant angle here is supplementary with this angle here because these are consecutive. So this angle must add to 180 degrees to equal 180 degrees with this angle, right? So all I have to do is I have to say it's 180 degrees minus the 20 plus the 45. And let me finish this math and I'm going to show you why this makes sense a little bit clearly. 180 minus 65. So this angle is going to be 115 degrees. Okay, SPQ is this angle right here, this one right here. We already said that any two consecutive angles in a parallelogram, so this whole angle here and this whole angle here, right here, are consecutive and they must add to 180. So this angle plus this angle must equal 180. So if I want to find out what this angle is, I just start with 180 and I subtract this angle off. But this angle is the sum of these two angles, so I kind of put that in parentheses here. So 180 minus this angle, which is this stuff in the middle, which is 65 degrees, gives me the 115. And the final thing we're going to do with this problem is SRQ. SRQ. What would that be equal to? SRQ is this angle right here, this giant angle here. Okay, SRQ. We already know that this angle here is the same thing, is going to be the same value as this angle here because these are opposite angles. And we just found that in the previous answer. So even without doing any math, you can write it down. It's going to be equal to SPQ, it's going to give me that. So we've covered quite a few properties of parallelograms. I'm going to write a few more specific ones on the board and we're going to apply those to a couple of problems, the same as we applied the previous ones to a couple of problems. Okay, so here's a theorem. Okay, the diagonals of a rectangle are congruent, which just means they're equal to one another. I mean, this is kind of common sense stuff. I mean, all this is really saying is if this is a rectangle, this diagonal is congruent with this diagonal, which means it's the same length. The reason you need to say that, though, is because if you look at like a parallelogram, that's not true. This diagonal is not the same length as this longer diagonal here. So that's why it's saying, as a theorem, you build things up. You know, it may seem obvious, but you'll be able to use these little nuggets of fact to be able to prove lots of problems for your homework and for your test. Okay, and then the second one that I'm going to have here is going to be the diagonals of a rhombus are perpendicular. That's very, very important. And they bisect the angles of the rhombus. This is really important to draw a really good picture. This is a rhombus. 4 equal sides, and 2 pairs of parallel lines. That's a rhombus. Now what this is talking about are these diagonal lines here. You draw a diagonal line here, and you draw a diagonal line here. All this is saying is the diagonals of a rhombus are perpendicular. All this means is that every rhombus you draw, the angle between one line and the other is always going to be 90 degrees. That means it's perpendicular. And they bisect the angles of the rhombus. So if you were to, look over here, these 2 angles right here are congruent. Okay? These 2 angles right here are congruent to one another. Okay? So these diagonals bisect the angles. It means it cuts it in half. So this angle here is the same as this angle here. That's all it means. If you look at a general parallelogram, where, a rhombus is a special case where the sides are equal. If you look at a general parallelogram, neither of these 2 things are going to be true. The diagonals are not going to be perpendicular, and they're not going to exactly bisect this angle into 2 equal pieces. Okay, so let's use these facts to solve a couple of little problems here. Okay, so let's say I have a rectangle like this. And this is going to be S and P and Q and R. Okay? And I've got a couple of diagonal lines. I'm not going to draw them in a different color because on your paper it's not going to be in a different color. The crisscross point is called O. This angle here, I'm going to draw an arrow, is 25 degrees. And the length of this line here, whoops, I drew the wrong thing, is 13. Okay, that's all I have. So what if I want to find, and this is typically how your problems will go. It'll say find QS. QS is the length of this here. Now, let's look at our theorem. The diagonals of a rectangle are congruent. This is a rectangle, okay? It's given to you there. And so the diagonals of a rectangle are congruent. So that means that this line is equal in length to this line, right? And also, you know that these 2 lines bisect each other. So this is 13, and this is 13. So this must be 13, and this must be 13, because everything is symmetrical, and this is a rectangle here. So really all you need to do is, this has got to be 13, plus this is going to be 13, which is going to be 26. Okay? And if you look at OP, well, how would you find that? OP, we just did the same thing as before. This has got to be 13, okay? Because this diagonal is bisected by this line here, so this line is going to be the same as this line, and we already know this is 13, so that's got to be 13. Okay, let's look at angle QSR. QSR, which is this one right here, this angle right here. I'm going to show you what that is. That's going to be equal to 25 degrees, same as this one, but now we need to talk about why that's the case. It's because if you remember back long time ago, when we had the 2 parallel lines and the diagonal that cut them, we said that this angle was congruent to this angle. They're the alternate interior angles, remember? And you can kind of see that they're congruent here, the same as you can kind of see that they're congruent here. But this goes back to that parallel line thing. We have a parallel line here and a parallel line here, and we're slicing through it with one long line like this. And so this angle must be congruent to this angle. If you've forgotten that, go back to that section on parallel lines and you'll see that that's the case. So this angle is congruent to that, and that's why it's equal to 25 degrees. And finally, number 4, angle RPS. Okay, RPS is just going to be this angle here. What would that angle equal? Well, we know that this entire angle here has to be 90 degrees, this one here, but we're only interested in this part of the angle right here, so all we have to do is subtract off 25 degrees, because this angle is going to be 25 degrees, same as this one, and you can kind of see that from the symmetry, okay? And that's going to be 65 degrees. Okay, last problem. This is going to be a rhombus problem, okay? M, J, K, L, okay? It's going to be bisected just like all the other ones have been. And all I'm going to be given, this is the crossing point is called N, and the only thing I'm given is that this angle is 25 degrees. That's all I'm given. And I'm going to find a few things here. What is angle JKM? JKM, which is this angle right here. Okay, what is that angle equal to? Okay, well, we already said over here that the diagonals of a rhombus bisect the angles up here. So you can see that here, we talked about here. So this angle must be equal to this angle. So this is 25 degrees because the diagonal bisects the angles in the corner. Okay. Next, we want to find angle JML. JML. This giant angle down here. Okay. And we already know, again, that this diagonal bisects this, so these two angles are the same. We already know that this is 25 degrees, right? So 25 plus 25 is equal to 50 degrees, okay? So that's the angle. JLM is 50 degrees, okay? Angle KLM. Angle KLM. KLM, which would be this angle, this big giant angle here. Okay, we know that for any quadrilateral, two consecutive angles have to be supplementary. So we're going to say 180 minus this angle up here we already said was 50 because this angle is 25 and this is 25, so this whole thing's 50. So this has got to be 180 minus 50, which is 130 degrees. Okay, so again, we're using these things that we've written on the board, these theorems, and they seem all random and disconnected, and you're just going to have to remember them, and here we are applying them to a problem. So we said that this angle, this big angle here, is supplementary with this angle here, because that's the way it is for quadrilaterals. We know what this angle is. It's 50 degrees. We already found that. This is 50 degrees, so then this is just 180 minus 50. Number 4, angle J and K. Okay, J and K. This angle here in the middle, what would that angle be equal to? Well, this is a rhombus, we told you that. And the theorem over here says that the diagonals of a rhombus are perpendicular. So by inspection, because you know this is a rhombus, that's 90 degrees. Because this is a right angle, because they split each other like that. And that's what we talked about over here. Okay? And the final one we're going to do in this section is K and L. K and L. This angle right here is the same thing. It's 90 degrees. Because it's just as before. It's a diagonal, it's a diagonal and a rhombus, so that when they both cross each other, they cross at 90 degrees. So this has got to be 90, this has got to be 90, this has got to be 90, and this has got to be 90. My picture doesn't really look exactly like that, but because I told you this is a rhombus, you can conclude that from the theorem. They cross each other, they are perpendicular. And perpendicular means 90 degrees, so all the angles here have to be 90, and that's why those are 90 degrees. So in this section, we've talked a great deal about quadrilaterals. We've talked about trapezoids and isosceles trapezoids, and we've talked about parallelograms. We've looked at lots of theorems, and we've used those properties of those things to find a bunch of angles on a bunch of sides. And that's where geometry can get confusing sometimes, because you get given a picture and you're like, gosh, I don't have enough information to find what I need to find, what they're asking me to find. Well, you need to go back to your theorems and really memorize them and really play with them and practice them so you know what they're telling you, so that when you get into those problems, you'll know where to go.
Learn anything at mathandscience.com.